SQL and AMP Database Optimization Techniques. They say data is the new oil, but raw oil is useless unless refined, and the same is true for data. You can store terabytes of information, but if your queries are slow, your structure is bloated, or your indexes are missing, then all you have is digital sludge. Welcome to SQL and AMP Database Optimization Techniques, where we turn bottlenecks into breakthroughs and raw queries into performance machines. Let's start with a brutal truth. Most SQL code written today is inefficient. Not because developers are lazy, but because databases have become so forgiving. With enough hardware, almost anything will run, but speed isn't the same as scalability. And in the real world, whether it's a fintech platform, a logistics pipeline, or a social network, inefficiency at scale means money burned. Now imagine shaving milliseconds off a single query, and then scaling that across billions of requests. That's not performance tuning, that's engineering leverage. In this video, we're not going to simply walk through queries. We're going to tear them apart. Because database optimization isn't about memorizing keywords. It's about understanding how your SQL interacts with memory, indexes, locks, and execution plans. We're stepping into the engine room. Let's look at how the database thinks. When you write a query, you're speaking SQL, but your database translates that into an execution plan. It decides which indexes to use, whether to scan or seek, how to join tables, and how much memory to allocate. If you've ever wondered why two nearly identical queries return drastically different results in speed, that's why. The optimizer chose a different path, and that's your power. Once you understand how to influence that path through smart schema design, targeted indexes, and clean joins, you can make a database dance. Take indexing, for example. Indexes aren't just accelerators, they're your primary tools for communicating with the optimizer. But over-indexing is just as dangerous as no indexing. It bloats storage, slows down inserts, and ruins cache performance. That's why real optimization isn't about adding more, it's about knowing exactly when and where to add less. Think about joins. Left joins, inner joins, cross joins, all powerful, all potentially destructive if misunderstood. Every join adds complexity to the execution plan. So what if we flatten our data instead? What if we denormalize selectively to optimize reads? Sometimes optimization means breaking the rules that textbooks taught us. And what about query plans? If you're not reading them, you're flying blind. Modern databases provide visual tools to analyze every operation your query performs. Cost percentages, index usage, scan types, it's all there. The difference between a 2-second query and a 200-millisecond query often lies in a single overlooked scan. Let's talk caching and memory. You can write the perfect SQL query, but if your database cache is cold or your buffer pool is overloaded, you'll feel the lag. Optimization isn't just what you write, it's when you write it and how often it runs. Scheduled jobs, batch processes, and heavy report queries all eat up your server's headroom. So smart data engineers don't just optimize for now, they optimize for tomorrow's workload. Ever heard of parameter sniffing? It's the silent killer of performance. Your stored procedures run fine today and crawl tomorrow. Why? Because SQL Server cached an execution plan for a specific parameter value. Different parameters? Same plan. Poor performance. The fix? Recompilation hints, query plan guides, and dynamic SQL when needed. Welcome to the nuanced battlefield of real-world SQL tuning. And don't even get me started on ORMs. They're powerful, sure. But if you trust them blindly, they'll bury you under a pile of unnecessary subqueries and N+1 select problems. Developers who understand SQL can bend ORMs to their will. Everyone else just prays their app doesn't crash under load. Let's zoom out now. Database optimization isn't about writing faster queries. It's about understanding the entire life cycle of your data, how it's stored, how it's accessed, how often it's updated, and by whom. It's about making trade-offs between read speed and write speed, between normalization and denormalization, between flexibility and precision. In high-stakes systems, financial trading, medical records, global e-commerce, poor database design can cost millions. But great design? It disappears. It just works. Invisible, reliable, blazing fast. That's what we're after. So whether you're a data engineer building pipelines, a backend dev writing SQL inside services, or a performance analyst staring at dashboards, you need to treat your database like a living system. Monitor it. Challenge it. Optimize it. Because the bottleneck of the future is not in your code. It's in your data layer. And here's the beauty. Every small improvement compounds. Better indexes, smarter joins, leaner queries, they add up. And when you scale that across teams, environments, and workloads, you're not just optimizing a database. You're building a system that wins at scale. Thanks for watching this deep dive into SQL and AMP database optimization techniques. If you found value in what you've just learned and you're passionate about pushing data systems to their limits, make sure to subscribe to the Data Superiority YouTube channel. This is where we build the future of intelligent, optimized, and scalable data architecture. See you in the next one.